Okay, problem number 5, and this problem is going to be about counting rules and definition of probability. We have a box which contains 24 transistors, 4 of which are defective. If 4 are sold at random, find the following probabilities. Exactly 2 are defective, none is defective, all are defective, and at least one is defective. A very common mistake in this case is to use binomial distribution. And this is wrong because we sell transistors. We sell transistors, we do not put them back into the box. Okay, we do not replace them in the box. So it means that the number of the transistors is going to be reduced, yeah, and that is going to affect probabilities of next events to happen. That means those events are not independent, yeah, and that's one of the conditions of the Bernoulli's experiment where you use binomial distributions. All events must be independent. Okay, so which is not the case here. That means we cannot use binomial distribution formula. Instead, we are going to use the multiplication rule, and we are going to use combination rule, and we are going to use definition of probability. Okay, so the first case. First case, we are setting 2 defective transistors, and then we sell 2 non-defective transistors. So we have 2 events. This is going to be our multiplication rule. And in order to calculate in how many ways those events will happen, we will use combination rule. Okay, so the first one, so this is equal to, and the first event we are setting 2 defective. So 2 defective transistors, and in how many ways we can select 2 defective transistors out of 4. So this is going to be combinations, and this is 4, this is 2. And then 2 non-defective, we are going to use combinations, and we have 20 non-defective, and we select 2. Yeah. So we have n different items available. We select R of the n items without the replacement. We do not do the replacement here. And we consider rearrangements of the same items to be the same. Yeah, the order is not important. Yeah, the order is not important. So we don't care which defective transducers we are selling. So what matters is only that they are defective. Okay, and divided by combinations, so that's number of different events, simple events. In this case, that's in how many ways we can select 4 transistors out of 24. Okay, that's it. And probability is about 10.7%. Okay, so none is defective. So here we are selling just 4 non-defective transistors. So here we have only one event. Yeah, and this event can happen in how many ways? So that's combinations. We have 20 non-defective, and we select 4. And again, we divide by number of different simple events, so which is selection of 4 transistors out of 24. So 24 and 4. Okay, around 45.6%. All are defective. So same thing here, we have only one event, and we take 4 transistors out of 4, and we divide by number of different simple events, and this is going to be combinations 24 and 4. So not really probable event. Okay, and the last one. At least one is defective. At least one is defective. We are going to use complement. That's 1 minus None is defective, so which is B. Okay, and that's it. Yeah, so that's it. So something similar you should expect on the midterm exam. Okay. Okay, so that's it, and let's move to problem number 6.